We've managed to get the data collection. Now it's time to deal with saving to the database. The database we'll use will allow us to store data offline. This means that we'll have access to it without an internet connection. We'll have multi-user support, so the user will see his or her data without the need to synchronize with the server. First, however, let me tell you a few words about SQlite. It's a database built in Android. SQlite is an open source project. Because it's very light and simple, it can be used on mobile devices. A huge advantage of SQlite is that it supports SQL version 92, which allows, for instance, handling join. At the same time, the entire database is stored in a single file, stored in the application sandbox, that is, a directory which belongs only to the application. Thanks to this, the file can be transferred between devices and the operation is very simple. From the point of view of an Android programmer, access to the SQlite database takes place using SQlite DBHelper. This is the main class which deals with the creating, opening, and sharing of databases by the programmer. The programmer may later execute queries on the database and modify its contents. A very useful option, particularly at the stage of application testing, is access via SQlite 3. This is a simple tool available from the command line which allows the execution of queries directly on the database. SQlite 3 is accessible both from the SDK level on the computer as well as from the device level. When connecting via a DB shell, we may access the application's home directory and execute commands directly on the database without the need to download the file to the computer. We'll illustrate the capabilities of the SQlite database with a specific example. We'll create a database which will store tasks as well as permit us saving and reading. With this, we'll be able to store data in the offline mode. In order to facilitate communication with the database from the application point of view, we create a DAO. In our case, it will be a to-do DAO, that is a data access object. This is a special class which allows packing database abstraction and access via sending basic model objects. We'll have a to-do object which we'll be able to save, read, and modify. In order to use the DAO, we'll also have to create a DBHelper. It's our implementation of SQlite DBHelper, which will deal with creating and sharing databases with us. We'll save the data we'll get from the server to the database, and then we'll extract it using the cursor. The cursor is a special object whose task is to indicate the results of the query, line by line. Thanks to this, we may download subsequent elements without the need to load everything at once. We'll display particular lines only when needed, taking advantage of the fact that the cursor moves over subsequent elements in the table. We'll start by creating the DAO and the DBHelper needed to manage the database. We return to our project where we'll create a to-do DAO class. The goal of this class is to communicate with the database. From the point of view of the rest of the application, no knowledge about the queries executed below is necessary. We'll just operate on model objects. Before we start using the DAO itself, we need a DBHelper inside. We create it as an internal class, which has to expand SQlite Open Helper. The class implements certain methods which we have to implement. These are the onCreate and onUpgrade methods. What is more, the DBHelper requires a constructor. In the simplest version, the constructor takes 4 parameters. First of all, the context, which we'll pass as getApplicationContext or activity. The next is name, that is, the name of the file with the database. Factory is an object that is responsible for creating cursors in case they are not standard ones. In our case, we'll use only ordinary cursors, so we can simply pass a null. The final one is version. It's an identifier in the form of an int, which specifies the current database version, including the application version. If we create other versions and release updates, but at a certain point decide that the database has to be changed, we have to upgrade the version to a higher level. This way, the system is able to recognize that there is a need for a database change during an update. That's what onUpgrade is for. In a moment, I'll tell you exactly how to use it. Meanwhile, we'll need a large number of constants, including, for instance, the database name, its version, as well as all the names of the tables and columns we'll need. That's why we'll use the file attached to this module. We'll copy the constants referring to columns, table names, database names, and the current database version. The parameters needed in the constructor can be filled in with constants. We can provide db_name for name and db_version for version. As I've mentioned, factory should be a null. Because we don't use many parameters, we can simplify the DBHelper only to the context. We'll need to pass the context only to create the DBHelper. All the rest will be defined based on the constants which we already have. The constructor is already implemented. There are only 2 methods left for us to implement. The most important one is the onCreate method. Its task is to create a database the moment access is required for the first time. This is pretty important because we can have an application installed for a long time and started several times, but until we try to execute a database query, the database is not created. The moment it turns out that the database is needed, the onCreate method will be called. Its task is, for instance, to create a database structure, perhaps fill it in with basic data, set the dictionaries available in the database, and so forth. The onCreate method takes the database as a parameter. In our case, it's SQlite database. we can call various commands on this object. We can execute SQL queries like insert, update, or even database modifications. In our case, we'll want to call the execSQL method and pass it to the SQL, whose task will be to create a structure. In our case, a to-do table. In order to limit the amount of code we need to write, again, we'll use the existing code. In the attached file, we have the onCreate method where the SQL generation takes place. The SQL created this way is passed to the method. Now, let's briefly discuss the query itself. Its task is table creation. The syntax is typical for SQL. After create table, we enter the name of the table, and then, in brackets, we provide all the columns which we want to create inside it. For each column name, we specify its type and possible additional options. In our case, it's, for instance, a done value, which will be cast from a Boolean to a binary value. We log the ready query, so we'll be able to see in the logcat what our query looks like after formatting. Now we execute the query. We get the database, which includes one table named to-dos, which includes the following fields: ID, content, done, user ID, created at, and updated at. Now we just need to implement the onUpgrade method. This method is called the moment the current database version is higher than the version which we currently have on our device. As soon as the update appears, the current database version on the device is checked, as well as the version which will be introduced by the update. If the versions differ, the onUpgrade method is called, which, apart from the database, takes the previous version and the new version. Thanks to this, having both versions, we'll be able to implement migration logic. We execute the right queries, which may be, for instance, alter table or the creation of entirely new tables. Possibly, we can also download data and save it back to the database in a different format if the changes were significant. The simplest solution is to delete the entire database structure in the previous version and start the onCreate method for the new version. This way, we lose the data the user had so far, but there is no problem in case of migration. However, this is an extreme measure and should be used only in case we aren't able to easily migrate data. As we currently don't know the new database structure, we can leave the method empty or implement the version which will always remove the database and create a new version of it. We have a sample query in the attachment. In our case, as we create a single table named to-dos, we just need to call the drop table if exist method to reverse the process. Then, we call the onCreate method, which will be executed in the new version, due to which the database will be rebuilt.